My friends, welcome to my 200 3D CAD models in FreeCAD series. Today I will be working on exercise 173, which is a simple object. And I thought, what if I wanted to build this object both in part and part design side by side, so we can see what are the differences between these two workbenches, especially the workflow, and also what are the similarities actually between these two. In that case, what I will do, I will open up another file and then import the same image and then process these both images and save them as part and part design file name. So be right back. Alright, so I have calibrated these both images and then placed the center at the center of this big hole. Let's take that x-axis away now. So I have both part and part design files saved. I'm gonna go ahead and tile these two windows side by side, so that way we can compare our workflow on both models. So part on both models, the first thing is to build this lower base. It would be one sketch. So I'm gonna go ahead and actually build this sketch on part design model, right? So this is the part design model, and here I want to start with building a new body and then build a sketch on XY plane, right? And here the sketching part is very simple. So it would be a rounded rectangle and with corner of 10 millimeter radius. And then I'm going to go ahead and quickly make this symmetric and make these two edges equal. So that's essentially making it a square. And then say this is dimension 70. So that's our outside. Now I want to draw 4 circles of outside radius 15. And easier part is to actually apply the dimension into the one and then take the rest of the 3 and apply a equality constraints. So there it is. And also maybe get this center one there. So this is 30. Okay. So this is our first sketch, and the sketching part is same in both workbenches. Okay, it moved over on this side. So what I will do is I'll take this sketch, copy and only this sketch, and then paste it on the other model here, the part one. I can do that. So it is placed because both of the images has the same center. It would just place it over there. We can see that it's there. Okay, and now what I can do is, so this is the part design. In the part design, I can come on the sketch and then build a pad of 10 millimeter. There is that. And we can do the same thing on part workbench. Now having this set up as a tab like Microsoft Word interface, it makes it easier to switch between different work groups, which is called workbenches in here. And I think this makes more sense. So I come to part and take the sketch and then make an extrusion of 10. So there is that. The first difference between these two is it is called pad versus extrude in part and part design workbenches, but it's the same, essentially the same thing. So we have it there. And then now the next step is to, when it comes to part design, we must have to build these 4 corners or the big cylinder in the middle as the second step. In part design, we have a little bit of freedom. We can actually take this and then copy and paste it 40 millimeter above. So that's either build these corner holes, but part design it had to be a continuous progression. So let's pick that. We will build 4 cylindrical holes in here. Okay, so we can do one corner and then array it at 4 sides, or just we can build the whole thing. So I think in part design one I'll do first, and what I'll do, I'll just sketch on XY plane and do the one corner. So this is radius 15 outside and inside radius of 10, and then I want to fix that center 25 on this way and 25 that way. So it's there is that. So this pad had that hole 25 on both sides at the corner, and then the outer diameter was 15. So we have this outer diameter 15 on this sketch, so they will just be on top of each other. That should be fine. All right, and I can actually take that and come in and paste it in part workbench as well, or in part, which I like most is the primitives. I can go ahead and build actually a primitive tube. So it would be outer radius 7.5, which is diameter 15 and inner diameter 10, and then height, we can build the height at the same time. So that is one good thing about part primitives. And I think we flipped each other, so it would be 5 there. So we got that, and the next thing is to actually adjust the x and y, which was -25 and -25. So there. And in part design, we pad that up to 55. So now both models are at the same stage of the progression, where we have one cylinder at the corner. Okay, the next step is to actually replicate this cylinder, this tube, 3 more times, and we can do that in draft workbench for part, or we can do it in part design essentially within the same. So here we can come here to linear pattern and actually select this pad first, and then come to linear pattern and say occurrences, I want to say 2. And I am thinking maybe it would, because it's only 2, here I can do a multi-transform in part design and take this one, mirror it over on this side. So right click to add, I want to mirror it on say YZ plane. So that would be YZ. So that we got that. And then I can add another mirror transformation, and you can say XZ. So we have that placed in there. So we could do the array thing, or we could just do the mirror thing. So there we have our 4 corner tubes. Let's do the same thing on part. Here we will just do 2 mirrors. So one mirror, I'll do it against XZ plane and take these 2. So this is an additional step compared to part design. I'll make that a fusion, put them together, and then mirror it again against, I'm going to say YZ plane there, and then place them together again. So we did 2 Boolean operations, fusions, in this mirroring 2 times in part workbench. In part design, in the multi-transform, the Boolean comes as a given operation between 2 phases. So we didn't have to do that, but the multi-transformation would be the one, because the part design does not offer you 2 successive mirrors of same body. But so we are at the same, again, at the same progression of the model building between these 2 workbenches. The next thing, we can go ahead and take this one, place it 40 millimeters above, and that would be, I think we can copy and paste it, we can clone it. So I'm going to go ahead and do it clone on part design. Okay, so the next thing is to place this pad 40 millimeter above from the base, and we can do that easily in part. So I'm going to go ahead and take that actually easily. So in part we have not actually fusionized these two, so they're still separate. Even if we did the fusion there, it should not be a problem. I can take that, rename that as base pad, and copy and paste it. So I want to copy this with this sketch as well and paste it there. So we have this base pad pasted. I'm gonna say second pad, and come here. I can do either of the two things. Now I can come here in the base pad, and in the position wise I can say on the Z direction it's 40. That places it where we want. So we can do that, or we can go into the sketch, because we copied the sketch we did, and then actually place that sketch 40 millimeter above. So that sketch is now, so if we hide this, bring this sketch up, so here it is. So that's the second sketch. So we can either of these, we can actually place that at the vertical position and then do the padding. So either of these two. So let's see what we can do in here. So here, this was the original base pad, this was the corner tube. So I'm going to go ahead and rename that. Although they are fusionized already, I can take this and copy it. I don't think I need the XY plane, so I'm going to take that off, and I still want that sketch in there. So we copied that and paste it, place it in the same body, right? And we can make that visible by pressing space. And here I can say it does not give me that location, but should not be a problem because we have the sketch in there. So we have this sketch, and I can go in the attachment, not in the position or in the base. So in the attachment I can go and position, I can say this is 40 millimeter. All right, now that sketch is there, we can see it, and pretty cool. So we got these two at the same level of progression one more time. We're almost there. Now all you have to do is build the center tube and call it a day. So that should be easy. There should be another sketch on XY plane, or I think I could actually build that. Yeah, it will be another sketch. So now we are in the part design one. So let's go to part design and actually delete that sketch. So I want to commit from here on XY plane and do an inside diameter of 20 and outside, actually it will be 22, and outside diameter of 30. Okay, I'm gonna go ahead and update these at 22. Okay, so it is partially redundant. I don't know what it is. Let me actually delete that and see how. Okay, I place these two at the coincident, and that's a fully constrained now. So we have that sketch. So that is center tube sketch, and I want to extrude that for, I think it was 70. Yes, so that's 70 millimeter. All right, we got that taken care of. I don't think so. Here it is one thing. I don't think that tube goes all the way through. So that was my bad to begin with. So that we will have to update that. So this sketch actually will be at this point, at this level, which is 40 from the above, from the base. I'm going to go ahead and actually change the attachment to Z as 40. There. Now I can go ahead and say this is 30mm pad. All right, and the inside tube, it says the smaller one. It's not the bigger one, actually it should be the smaller one. So I will have to go back to the base pad and change its diameter to 22. Okay, I think that's it. That's the completed project in part design, and we will fix that mistake in here as well. So come here to the base pad, make this 30 as 22. Cool. And because we copied this one with its own sketch, that is still showing 30, which is fine with me. And what we want to do is I want to take this sketch from here, copy it, only the sketch, and come to the part one and paste it over. I think it's at the same location now, and then extrude that for 30. Oopsie. Something, okay. And because we copied and pasted it from part design, I think I'll have to reorient that sketch just a little bit. I'm gonna say reorient sketch on XY plane. Right, so that's one way to fix the plane. So now this is sitting at the bottom. I'm gonna go ahead and update the placement. So it was attachment in part design, it's placement in part. I think these two different terminologies, or like two sets of terminologies in two workbenches, can be unified. I mean, it's not a big deal to change the name, but anyway, so we did change the attachment or the placement, and then now this is at the same location. So here is the finalized object in, so this is at, so this is part design, this is part, and let's see the main difference. I think, in my opinion, between these two workflows is the Boolean operation, and also the attachment. These sketches are attached differently, I guess, between part and part design on the base axis, or like base planes rather. But essentially the same workflow. The only benefit, definitely a benefit in part design, is I don't have to worry about the Boolean operations. So every step there is one Boolean operation applied on the successively, where I'll have to come to the part and pick all the different parts and apply a Boolean operation at the end. Unless it was a mirror, I'd have to do it at the right away for a two-step mirrors, which was easy on part design. And also one benefit I always have enjoyed in part workbench is it doesn't have to be continuous modeling. I can, different models has different workflow favorable, and if it becomes a separate body, separate parts in the same body, part workbench actually helps build that. And I want to finish this comparative video with a note from the Wikipedia of FreeCAD. So here's the link, wiki.freecad.org/part and part design, and here it describes these differences between here, and one line is really important in this discussion. On the overview side, it is said it is a good idea to use one or the other until the user is comfortable with one, then learn the other. What it says is pick one, either part workbench or part design, and get fluent using that workbench in FreeCAD, and then maybe try to approach on the other workbenches. It is also typically recommended that new users not mix them until the ramification of doing so are understood. And the main ramifications would be like the per design contains everything in one body to work with, whereas part actually can work on different bodies at the same time, and mixing them together often doesn't work. And I have found different workbenches compatible, easily compatible with part workbench, whereas part design creates a base model when trying to take parts from other workbenches to the part design. But anyway, I just wanted to put it out there for like there is a lot of discussion between two workbenches, and I think until these two becomes one, which is my prayer, this should be consolidated in one. Take the strong sides from part, take the strong sides from part design, and just call it like one workbench, and have the same terminologies across both systems. Until then, start with one, get comfortable with that one, and then maybe experiment with the other. So I hope you like this process and appreciate this discussion. If I have missed anything, or if there should be something else as well included in this discussion, please let them know in the comment section below. And thank you for watching. I'll see you in the next video.